Welcome to this overview of new features in Mechanical Release 2019 R1. In addition to having a new release designation, Mechanical Release 2019 R1 has many new features and capabilities. This video provides a quick look at these new additions. A significant new feature is the ability to couple harmonic response analysis with Maxwell to perform a simulation of noise and vibration in rotating electric machines. For any rotational velocity that you analyze in Maxwell, loading is transferred to mechanical as remote force and moment loads, or as surface force density loads. New step controls and properties enable you to modify load values, and new result options enable you to examine structural vibrations for a range of rotating conditions and frequencies. The solution combination feature has been expanded for 2019 R1. It now supports harmonic response and transient structural analyses. The redesigned worksheet facilitates the efficient definition of solution combinations and the specification of multiple combinations, as well as the addition of a multiplication coefficient, quadratic SRSS equation support, import and export to Excel, and new result display options, enabling you to pick between displaying results using tabular data or a result set number. The new part transformation feature enables you to specify model transformations to modify the position and orientation of the parts in your model. The Symmetry feature now offers a new symmetry type for 3D static structural analyses, general axisymmetric. This feature enables you to create an axisymmetric mesh in the circumferential direction on a surface body model that is based on specified nodal planes and an axis. Using this feature, you can apply non-axisymmetric loading on an axisymmetric model. The substructure analysis now supports the component mode synthesis (CMS) matrix reduction method for MSUP harmonic response analyses. CMS reduces overall computational time, allowing you to solve very large MSUP harmonic problems with limited computer resources. You can now open Mechanical without a geometry, define environmental conditions, and essentially create a template that you can save and then reuse with different geometries, and then attach a geometry. Furthermore, you can use a new option to replace your existing geometry. Arbitrary cracks can now span multiple faces. You can create corner cracks as well as straight cracks. Two new connection-based enhancements are available. The connection group property, face-face angle tolerance, used to define the minimum angle between two face normals. And the formulation property for a bushing joint has a new option, bushing. Previously, only MPC was available. These options specify the element type to be used. Several improvements have been made for topology optimization analyses. Most notably, the smoothing result option that enables you to create a smooth geometry based on the parent topology density result and object automatically create an STL, stereolithography, geometry file. You can now optimize an upstream steady-state thermal system, including a new thermal compliance response type and temperature constraint. For the simulation of layer-by-layer additive manufacturing process, a new layered tetrahedrons mesher creates a tet mesh that conforms to a specified layer size. It captures geometry well and is useful if your part has small features, such as holes, or for thin-walled parts and supports. You can now simulate heat treatment following the build process using a new heat treatment step on the AM process sequencer. Mechanical now offers a keyframe animation feature that enables you to string together snapshots of your model in the geometry window to create an animation. You can now animate a result based on predefined keyframe animations and synchronize the result's animation to the keyframes. You can now create multi-line names for your project. Use the key combination Ctrl-Enter to break the lines as desired. The material-dependent damping property, constant structural damping coefficient, from the engineering data workspace is now supported for full transient, full harmonic response, full damped modal, and reduced damp modal analyses, when the store complex solution property is set to yes. You can now transfer hydrodynamic surface pressures and beam loads from a hydrodynamic diffraction system to a static structural analysis to support the design of offshore structures.